Hey guys, how are you today? Today we are going to look at how Docker image works. In the last videos, we have seen a difference between virtual machine and container, and we also saw how namespace and C groups are providing the isolation that we have within the containers. And in this video, we are going to take a deeper look into what is known as Docker image and file system as well. So Docker image is like a blueprint or architecture for the container which is going to run. So this is like architecture or blueprint for the container that is going to run. So this architecture or blueprint will have few things. First of all, it will tell what is the user ID that is going to be used to run this container. And then it will also have things like environment variable. And we will also have the programs that are going to run inside the container. In addition to this, we'll have layer of file system. So let's call it file system. So the file system is basically the user space operating system files and also any programs that we want to run. All of them are going to be part of this file system. This file system is actually something special. So this file system is the one which is going to be mounted as root file system for the Docker container which is going to run. But the image itself is going to have the files that are going to be part of that file system. And this file system is layered. Okay, so this is not one level file system. This is layered, and each layer is actually immutable. So in the base layer, we'll have something like user space OS files, and on top of that we may have some of the dependencies that we use for programs. I'm just making this arbitrarily. There is no strict rules in terms of what should be in what layer. Okay, obviously if we have something depends on the layer below, then we need to build a layer on top of that so the dependency chain is properly wired up. But other than that, you can actually create them in any order. So if we go with my example, we have the underlying user space operating system files, and on top of that we have some dependencies that our program is going to depend on, and on top of that, let's say we have our program. Okay, so it could be a web application or whatever that we want to run inside the container. Now each of these are layers and these are immutable, and they'll also have unique hash. So they call this as content addressable hash. So this content addressable hash is going to uniquely identify this particular layer. So for each of the layer, we'll have a unique content addressable hash. Usually this is SHA-256. Now, on top of this, we are going to have thin writable layer. Okay, so let's call this writable layer, and this writable layer is not part of the image. The image is going to have user, environments, programs, and then this layered file system which provides the actual file system when the container is running. Because this is actually a layered file system, this has few advantages. If this image, if this layer is shared by multiple containers, then you will just have one copy of that layer in your file system, basically in your host file system. It will not be duplicated. And for registries like a Docker registry, this is also efficient, because if multiple containers uses some of these layers, then Docker registry doesn't need to store them separately, because they are going to be same with the same content addressable hash. Docker registry just need to store it only once in its registry, and all the images will share the same layer. So that is the idea behind this layered file system. So when you are pulling this image from Docker registry so you can run a Docker container, then if a layer already exists in your file system, then that layer won't be pulled. Only the missing layers will be pulled. So when you run the Docker container, it will take all of these layers and it will merge them. It will merge them using something called union file system. And this union file system will provide one merged view that is used as a root for the container that you're running. And this thin writable layer that you have on the top is not part of the image, but when you run a container, it will be available on the top. This is where all the read writes will happen. So if you are adding a new file, the new file will be added to this new, the top thin writable layer. And if you are modifying a file from one of these underlying layers, because these layers are immutable, you can't directly change those files. The file that you're changing will be copied to the top writable layer, and then the file will be changed. And similarly, if you're deleting a file from one of the images below or one of the layers below, then the writable layer will make it look like the file has been deleted, but the underlying layers in the images won't be changed. So that is for storage efficiency. Basically, the layering approach is introduced by Docker for storage efficiency. So now we have looked at what is Docker image. Docker image is actually architecture or blueprint for the container which is going to run. It is going to have few information. It will have information like, what is the user which is going to be used to run the container. And then if there are any environments variable, we'll have them. And we will also have what programs we are going to run inside the container. And then we'll have the file system. The file system will have a layered file system. Each layer is immutable. We will build from, the base operating system user space files to dependencies and the programs that we need, like in a proper dependency order. And then when a container is running from an image, the architecture or blueprint will come to life. And that time, there is something called union file system, which will merge all these layers and make it look like one normal file system that you have mounted on the root of the container which is running. Okay, so that is what a Docker image is, and that is how it works behind the scene. I hope this is useful. Thank you.